Okay, so this is actually going to be a good lead-in from the last presentation because I'll mostly be focusing on actually using large language models and chatbots to talk to your data and kind of use them as a way to explain the contents of a database or a collection of articles. Okay, but firstly, a quick note. As mentioned earlier, I'm from Ontotext. You've seen us at these previous events, and we're one of the organizing organizations here. We're also undergoing a merger, so if you see things like a banner saying GraphWise, that's still us, and we're still doing the same things. Just putting that quickly out there. And in fact, the purpose of the merger is to, in fact, become even better at the kinds of things we're doing. So what my company specializes in is using enterprise data sets of heterogeneous and multimodal data, combining them into cleaned up knowledge graphs, connecting them to external knowledge, to linked open data, and producing more understandable full data sets with very complex knowledge in them. To that end, we have many projects that specialize in given domains and build knowledge graphs around a specific domain, and then that's delivered to our clients as a way to get insight into their data. How this is relevant here is the database of known fakes. It was mentioned yesterday. It's been under development and been expanding for several years now. Currently, it's being developed under the Vera AI project that some presentations yesterday mentioned, and also the broad local Edmo hub. So it's a database that collects a lot of disinformation claims and debunking articles. Currently, it has about 150,000, but it's about to undergo a large expansion and go over well over 200,000 in the next few weeks. The point is there's a lot of data there, so a lot of articles it's built on. They've been analyzed and built on top of, according to a ever-expanding data model that kind of describes what's in it. So this is a very simplified version of the data model, but there's still a lot of things here. The general idea is that we're treating these documents that are being collected, like news articles, social media posts, debunking articles mostly. We extract their contents according to modality. They are run through different machine learning and AI tools to do automatic analysis that produces different kinds of enrichments and insights into the data. We're talking here about concepts mentioned in the texts, events, which are kind of like whole sentences describing something specific that happened or claims to have happened. And we also have a first step towards narratives, but we're focusing on specific clusters of content reuse. And there's also external knowledge pointing to the sources of the data, like who posted it, who's the publisher, who's the author, how it was transmitted, where it was encountered, what are the different connections between the documents. So this is a rather complicated ontology. You can ask it a wide variety of questions. And we have correspondingly built a wide variety of services to query the collected data. So you can do full text search like Google searches. You can do multilingual searching. You can filter data by facets. You can do semantic text search. So that's the very popular RAG approach now. Or you can do visual similarity for images and videos. We haven't released a service for it, but it supports audio similarity as well. And of course, there's the underlying database interface, so you can query everything in very complex ways using Sparkle. And the user, which ideally would be journalists and regular people, as well as data scientists and knowledge engineering experts. The user has access to all of these things. And most of the users, even ones that are specialized in working with data, take quite a while to figure out how to use all of them. And they might not be sure what is the best tool in different situations. To that end, we are experimenting with introducing a chatbot, so a large language model that's instructed in all of these things I mentioned. They know, they have access to the database, they have access to all the tools that can be used to search it, they have an explanation of what's in the database, what the data model within the database is, and ideally here, you as a user just ask regular questions in whatever language you prefer, and the chatbot figures out how to extract and summarize the information for you. Now what this actually looks like, here are some examples. So you can ask it things like a simple question, who are you? And it will explain that it's a chat agent, what it's working with, what kind of data it knows about. And you can have a conversation on that level where it's just explaining the high-level ideas of what's in the database. You can always also ask specific questions. So a very simple kind of query for anyone who can write Sparkle, but hours of effort for anyone who can't, would be what are the 10 most recent claims about climate change that you're familiar with. And the agent automatically writes that query, collects the data, and gives you out text that's understandable and has links to the data where you can figure out where the articles came from, how it got collected, and so on. You can, of course, ask it increasingly more complicated questions, and it will continue writing Sparkle queries for them or using whatever other tools are necessary. So things like narrative clusters, which is collections of very similar claims in social media posts. So what are the most recently active clusters about climate change, or what is the most active one that was mentioned in the last year, or was the biggest one mentioned in the last year? And it would go and collect data. You can see it's giving you different results, but general explanations, and ties into the database if you want to dig down yourself. What's actually happening behind the scenes is that the agent has a description of all the different tools that are required to collect the information, and it's supposed to figure out which ones are necessary for a given question and how to use them. It will try to use them. If it fails or it doesn't get the results it's expecting, it will try to fix its approach, either use an alternative tool or use the tool it's trying in a different way. But the whole idea here is that behind the scenes, it's doing these multiple iterations of querying the database in different ways, trying to fix its errors, to extract the information for you. And if you're an expert, you can look at it, do all of that stuff. And if you're a regular person, you can just get an answer within a second anyway. But the agent is very strongly dependent on having clear instructions, a very well-defined ontology, and tools that provide it useful feedback so it can correct its approach. A more advanced user can step into this cycle to make even more use of the agent. So if I were to ask it something rather complex, like I want a month-by-month comparison of the number of claims that mention Trump or Biden alongside Kamala Harris. So it would go, it would figure out who Trump, Biden, and Kamala Harris are in the knowledge graph, how to refer to them, how to include them in the query. It will write a query and it will give me an answer saying like there's one claim mentioning Trump and one claim mentioning Biden alongside Harris, and they were both in April. And I'll go look at the query because I do know Sparkle, and I'll see that there's a bit of a problem because it only limited the question to the months of 2023. So I'll tell it that I don't just care about 2023. I wanted to do a year-by-month historical breakdown, and it would fix the query without redoing all the work from the previous time. It would output me the data, and I've made a graph here that you can't see very well, but it basically shows what we were expecting. There's perfect correlation up until Kamala Harris became the candidate, and then the debunks only mention her and Trump with no mentions of Biden afterwards. So it went and collected the data correctly with a little bit of prompting. One other note, you can, of course, talk to it in any language you want. This is very useful to make it more accessible because the large language models, most of them at least, are natively multilingual. So I could ask it questions in Bulgarian, and it would generally respond to me in Bulgarian, even though behind the scenes, it's collecting whatever data I'm asking for. So in this case, I asked it simply, how many debunking articles do you have in Bulgarian, or rather disinformation claims do you have in Bulgarian in the database? And then the second question is an example where I discovered a problem with how the ontology was being described because I had to do a kind of stilted approach to get the answer I'm looking for. I had to tell it that this complicated way of filtering results where I want you to find disinformation claim clusters that include Bulgarian, and have been active recently, and order them from largest to smallest. And the first time it tried to filter them, it kind of didn't do the correct way of recognizing the language. So I prompted it in a way that only someone who understands the underlying architecture can, which is I'm telling it use schema in language property, whatever. That doesn't mean anything to any of you. It does mean that I uncovered an issue with how clearly the ontology was described. So I went in the back and I clarified it in the instructions to the model, and the next time you could ask it the same kind of question with more natural sounding language and you'll get the same kind of results. And what really happened behind the scenes in that last question is it went and it collected a subset of the data that looks, this is not even the full subset it collected, it's a small chunk of it, but it basically looked at all of these different kinds of objects with all of these complicated connections between them, and it summarized it in a way that's readable to people. It's actually quite interesting. This is where the narratives come in, because there are over 120 examples of narrative clusters that have debunks in Bulgarian. So they usually only have one debunk in Bulgarian, but they've appeared in a whole number of different languages, usually in 5 or 6 other countries as well as in Bulgaria. So it's an example where this kind of conversation that's natively multilingual, that's easily accessible to people, can make the work of debunking journalists much more useful, because there are 120 clusters that have been debunked in Bulgaria, but we've actually identified well over 25,000 clusters of disinformation that's appeared in multiple languages already and been debunked by journalists in different languages. So this stuff keeps propagating, and being able to get answers that are understandable to you, even though the debunker didn't speak your language, and you might have trouble talking to the person who wrote the debunk, but then the chatbot can actually help you connect to the work they did and explain how it got its result. And really, this is kind of the main message from my approach. The knowledge graph backed LLMs have several very important features. Firstly, because the answers it's providing is based on an actual knowledge graph built out of real data, and we know where it came from and stuff like that. We have data provenance, so we can always tell you where the data was sourced, who wrote it, who took a certain position. There's no black box there. It ensures factuality up to a point. If you've collected good data, it will answer based on good data. That's not only the hallucinations that everyone has heard of, but a general example. If you use simple RAG and ask an algorithm, here's my question, find me the most similar answer. If you don't have that knowledge in the background, the algorithm doesn't make the difference between the disinformation claim and the debunking of the journalist. So it would happily return you disinformation claims because it doesn't know what's real and what's not. It just knows what's the most similar piece of text you have. That's not just the problem with LLMs, of course. If you're looking for results in Google, everyone knows if you want to get a specific result and you ask it to find you that result, it would find someone who claimed that's the case. So this kind of data factuality coming from the knowledge graph is important. It also makes the answers explainable. If the algorithm tells you, hey, this seems like this kind of false information, here's a cluster or whatever, whatever answer it gives you, it always also tells you, and here's where I got my data, here's the person that wrote the article or the organization that published it. You can go and look at them and decide whether you want to believe them or not, or whether they've done other work or updates, that kind of stuff. Accessibility in multiple languages I already mentioned. And of course, making it accessible through a chatbot, because the chatbot using the knowledge graph shouldn't come up with any kind of information that an expert couldn't query out to the knowledge graph, but it can actually query rather complex information. So who is this for? Regular users, so regular people asking basic or infrequent questions that would translate into relatively simple queries. They can keep using this chatbot to get answers to their questions, or semi-automatically it could kind of it could be as simple as a button. Like you find something suspicious, you click a button to ask the chatbot whether it's related to this information and stuff like that. It would give you an answer. But it allows you to freeform explore, keep asking for further clarification, stuff like that. There's also an opportunity for analysts and researchers to use it. So those are people that are comfortable working with data, but aren't necessarily familiar with the specific APIs of a given knowledge graph or database. So for those people, they can look behind the scenes, they can check what the chatbot is doing, like the example I had where it gave an answer I wasn't expecting, and I looked at the query and I clarified it and made it fix the query and actually get the data I wanted. So these more advanced users can get a more gentle and useful introduction into the knowledge graph. And then finally, data engineers and data scientists that might be actually building the data set. For people like us, it can make writing queries slightly faster, but really what it does is do a very good job of identifying problems with the data or lack of clarity with the data model. Because when the chatbot gets something wrong, it's almost guaranteed that the new person trying to learn how to use the system would also be confused by the same things. So in a way, it makes us do a better job and make the data clearer, more accessible, more well documented. And that's my presentation.